talked about. So I have a rectangle. Opposite sides are congruent, and its perimeter with base and height is 2 base plus 2 height. And the area is just base times height. Fantastic. Okay, what about a square? A square is a special type of rectangle where all sides are congruent, and the perimeter is with side length s is just 4s, and the area is s squared. Fantastic. And then a triangle, I'm going to draw any kind of triangle with A, B, and C. The perimeter, is A plus B plus C. Now, let's talk about area real quick. We had said that it's 1/2 base times height. But where's the height? Okay, I'm going to go ahead and switch these 2 letters, B and C, really quickly, and you'll see why. I'm going to call this B right here the base of the triangle. And the height is any line that I can draw from the opposite point, vertex. This is a vertex. It's where 2 sides meet in any polygon. I'm going to draw it from the vertex, the opposite vertex of the base, and draw it at a right angle. It's a 90-degree angle with the base. That is what the height is. Okay, so the height, again, I draw from the vertex down as a 90-degree angle, a segment that's a 90-degree angle with the base. So that is how I get my height. Base times height times 1/2, or divided by 2. Fantastic, guys. Okay, so let's talk about a little bit more about base and height of a triangle. So I can have the base that'll be here, and the height here. That's just one side of the triangle. I can draw another type of triangle, like I did before in the table we just made. I can draw A, C, B, and the height goes from the vertex, a 90-degree angle with the base. I can also draw a different kind of triangle. This angle we're going to talk about later, the base right here, and this angle right here, is going to kind of make this triangle, this vertex, extend past the actual length of the base. So if I draw a 90-degree angle, it's going to be outside of the base, but that is okay. As long as it's in line with the base, I can still draw the segment that represents the height of the triangle. So my base is right here, and my height, even though the segment is outside the triangle, that's okay. It's a 90-degree angle with the line that contains the base. This is the line that contains the base. Fantastic, guys. Okay, let's do one more example involving area and perimeter of a rectangle. I'm going to go ahead and draw another rectangle. Opposite sides congruent, which I'm showing you through my tick marks. And instead of giving you all numbers as your side lengths, I'm going to give you one pair of side lengths as a variable, 3x. The other pair, I'm just going to say 6. Now we have a variable. I wonder what we're going to do. So the perimeter, we can still say, is 2 times the base plus 2 times the height. That's our formula. It'll always be that way for a rectangle. Okay, well, let's go ahead and define our terms. Define what the base is, what the height is. Okay, so the base, I always want us to use the base as the horizontal side right here. Right here. So even though it's a variable, I'm still going to use, it's going to be 3x, and that's okay. That's our base, 3x. What's our height? Okay, our height, again, is this length right here. It's just 6. So now I can plug in my base and my height to my formula to find the perimeter of this rectangle. So 2 times the base, 3x, plus 2 times the height, 6. So remember, when we have parentheses, I'm going to distribute the coefficient is 2, into the parentheses and multiply it by the coefficient inside the parentheses with the variable. So 2 times 3 is 6, so I have 6x. Plus, now with this, I'm just going to multiply 2 times 6. Parentheses represents multiplication, so I have 2 outside the parentheses, 6 inside, so I'm going to multiply them together. 2 times 6 is 12. So let me stop here. Can I combine these two terms? This term has a variable in it. This term does not. So these two terms are considered unlike, not like terms. And because of that, I cannot combine them. I can only combine like terms. So this is our perimeter of a rectangle. Even though I had a variable, I can still find the perimeter. Oh, great, guys. Really good work. Okay. Let's find the area. Let's erase this real quick. Okay. So remember, the formula for area of a rectangle is just base times height. Well, I still have my variables defined here. Base is 3x, height is 6. So I can still say 3x, I'm going to go ahead and put that in parentheses, and then height is 6. Okay, so remember, parentheses means multiplication. So I can take 6 times 3 and get 18x. And that is the area of my rectangle. Great job, guys. About today is circles. Okay, so let's go ahead and draw a circle. There we go. I'm going to go ahead and draw the center of the circle, which is exactly in the middle. It has the same distance to any point on the circle. If you draw any segment from the center to the circle, it's going to have the same length. That length is called the radius. Okay, so the radius is from the center to any point on the circle. Okay, the diameter, I'm going to start at a point on the circle and draw a line through the center to another point on the circle. So you can imagine a diameter is like a line segment. You have an endpoint here and an endpoint here, and the midpoint is the center. That's the exact middle of the diameter. Okay, and it bisects the diameter. Look at all these great words we're learning. Okay, so this is the diameter. Very good. And then lastly, the last word we want to focus on right now is circumference. Circumference is if I started at a point in the circle and walked all the way around the circle, it would be that distance that I walked, the distance around the circle. So that is circumference. Okay, so remember, we have to talk about perimeter and area. Perimeter is actually circumference, so circumference and area of a circle. All right, let's go ahead and talk about circumference first. Okay, circumference is going to be pi times the diameter. Okay, diameter, I'm going to use lowercase d. Radius, I'm going to use lowercase r. Circumference, I'm going to use uppercase C. Okay, what is this number pi here? Okay, pi is actually, the definition of pi is just the ratio or circumference divided by diameter. It's the ratio of circumference to diameter. So I can rearrange the equation and say circumference equals pi times diameter. So that is circumference. We're going to do an example in just a second, but let's talk about area. The area of a circle. So I'm going to also use the number pi. It's a number. It's not a variable. It's an actual number. Pi times radius squared. So I take the radius and I multiply it by itself twice, which is what squared means. Let me go back to circumference really quickly. and mention something. I'm going to erase this real quick, give us some more space. Okay. The diameter is just twice the radius. So I can also say, we'll write 2 first, 2 times the radius times pi, because 2 times radius is just diameter. Okay, so there's 2 options I can use for circumference that will give you the exact same answer. Let's go ahead and that involves circles. Okay, so I'm going to give you a circle, and the radius is 4. So let's find the circumference. The circumference is 2 times pi times the radius. We just looked at that. So it could also be pi times the diameter. But since I know what the radius is, this is the radius equals 4, and I know that because it starts at the center and it ends at a point on the circle. So that is the radius. So radius equals 4. All I have to do is plug in, 2's a number, pi's a number, the only variable is r, plug in 4. Awesome. Okay, so remember, multiplication. The parentheses means multiplication, so I'm going to take my 2 and my 4, and I'm going to get 8 pi. Okay, let me stop right here. I can leave the answer as 8 pi. And I know that in middle school when you used pi, you used 3.14 to multiply, to use as pi. But 8 pi, this answer right here, to represent it as 8 pi is the exact number. And the reason is that pi is an irrational number. It is a decimal that goes on forever. And so I can never represent it as a decimal exactly. The decimal approximation of 8 pi is 25, not 24, 25.13. But it's only an approximation because I would have to continue on forever with these decimals to represent it exactly. Instead, I can just say 8 pi, and that is the exact number. Okay, if you want to test that out, take pi from your calculator and multiply it by 8, or 3.14 by 8, and you should get a number close to 25.13. Okay, let's do area. Remember, area is pi times the radius squared. We know the radius is 4, so all I have to do is plug in 4. Perfect. 4 squared. Remember, 4 squared just means 4 times itself. 4 times itself is just 16, so this is 16 pi. This is the exact answer. If you wanted a decimal approximation, then the approximate number would be 50.27. Fantastic. Great job, guys. Okay, do a little review. So, we've talked about rectangles, their perimeter and area. Perimeter is 2b plus 2h, and the area is base times height. Squares, with side length represented as s, is 4s, and the area is s squared. For a triangle, a perimeter, I just add up all the side lengths, like I would on rectangle and square. And then for area is 1/2 base times height. Okay, and then finally circle with radius r and diameter d. I can write circumference is 2 pi r or pi d, and area is pi r squared. Great job, guys. Good work. I will talk to you next time.